Okay, next we have Anton Savinov. He is currently an engineer with General Motors, where he works on simulations of high-performance vehicles on racetracks. His engineering education began in Gunn, where he participated in the Gunn Autotech program, the Gunn Robotics team, and the IAROC competition. After graduating Gunn in 2010, he went to UC Berkeley for a degree in mechanical engineering.
I'm Anton, and the slides aren't showing up. Well, we can wait on the slides. I guess I'll be starting with a video anyway. So, quick background about me. I went to Gunn and graduated in 2010. While I was at Gunn, I did Gunn Auto, which was huge for me because I'd been playing with cars since I was born, really. And Gunn Auto was the first time I really got to play with real cars besides my own. And I did robotics, where I realized that I didn't want to just draw cars or drive cars. I actually wanted to make cars. And then I went to UC Berkeley for mechanical engineering, where I did Formula SAE. And Formula SAE is very similar to the robotics team, except instead of building a robot, you build a race car, and then you go and compete with other schools. So then, after Berkeley, I went to General Motors, and people are now paying me actual money to play with cars, which is kind of neat. So what I do at GM is I do track simulation of performance cars. To give you guys some background on what I mean by track and what I mean by performance cars, I'm going to start by showing you guys a brief video. So if we could roll the video. Definitely going to want sound on that. It sounds really awesome. So this is the racetrack at where I work, actually. And so this is the main straight. The car gets up to about 160 miles an hour. This is a Corvette. And then you kind of go into the first corner. It's a corner that tightens up, so you have to watch out for that. These are what we call the low-speed S's, a lot of elevation change through here. And then this corner is called the toilet bowl, and it's actually got 30-degree banking on it, and it really loads up the suspension. So you see about 2 Gs in cornering and 2 Gs in vertical loads through there. It's really intense. This corner and the corner right after it we call the perumps, and those are actually long, steady-state corners that really work the oiling system in the engine. So the constant corner will actually push all the oil away from where the pump is supposed to pick it up, and then the engine starves of oil and dies. I wish we had sound on that video, but in any case. So I'll talk a little bit more in detail now about what I do. So what you just saw was the real thing, right? That was an actual Corvette going around a racetrack. That cost GM many thousands of dollars to do, but we still regularly do it when we need to. But there are many times when we don't need to do it, and we don't want to spend the money on it. So my job is to do what just happened in the video virtually. So GM builds dozens and dozens of different cars, but among them are also cars that we consider to be track-capable cars. So these are cars that GM believes customers will actually take them to racetracks, and we believe that the success of the cars in the marketplace hinges heavily on how well the car performs at the racetrack. So we design to racetrack use. Now, when you're building a car to be fast, there's a lot of things that you need to pay attention to, a lot of things you can change about a car to make it go faster. For example, you can put a bigger engine in the car. That'll make more power, and that'll make the car faster. But then, when you put that bigger engine in, That bigger engine needs more cooling. That bigger engine is on its own bigger. It weighs more. More mass means the car is slower. So there's a balance, right? You get more power, more weight. So overall, does it make the car faster or no? It's a good question. You could put the engine in the car and find out in real life, but if you don't have the car yet, or if you don't have the engine yet, you can't do that. Or if you don't want to spend tens or hundreds of thousands of dollars doing that, use simulation. So what we do is in simulation, we build a car. So we start by putting in numerical form. This is all numerical. The overall size of the car, the mass of the car, where the mass is distributed. We take the aerodynamic properties of the car. We put it in the wind tunnel and figure out how much drag, how much lift, et cetera, the car has. Or if we don't have a real car yet, we'll just simulate that too in a separate simulation. We look at the engine. So how much power does the engine make at different speeds? Now we look at the suspension of the car. How does the suspension move the wheels, et cetera? And finally, the most important part is actually the tires of the car. So if there's any single component on a car that determines how well a car drives, it's actually the tires. The tires are a very complicated model because a tire's behavior will actually change based on its current conditions. So if it's got a lot of load on the tire, it's going to have different amounts of grip than otherwise. So in my model, it all kind of just looks like graphs. But it represents a race car. So we take all that and we build essentially a physics problem, a math problem really, and put it into the computer and we solve the math problem. What do we get? Got a bunch of graphs. So now, after I build the model, my job is to look at these graphs and figure out what's going on. So you can kind of see in the top graph, there's the green trace, and then there's a fainter blue trace that occasionally deviates from the green trace. So both of those traces represent they're the same car, but with slightly different aerodynamic properties. And on the racetrack, they're going at different speeds in different places. So my job is to figure out, well, why is it doing that? And did that make it faster? And if it did make it faster, is that actually going to happen in real life, or is that just something that happens in simulation? So what I do is a little teeny tiny part of what happens at GM. GM's a huge company. And cars are really complicated. Cars have a lot of stuff in them. This is actually a cutaway of the new Volt that's coming out. And you can see the engine in the front. Then in the middle, there's batteries and things. And you can see suspension components out around the wheels. Every one of those components has an engineer or 2 or 10 or 20 working on just that component. Not only that, but there's engineers who work on those components when the car is still kind of being architected. So there's engineers that work on those components purely in the virtual world, kind of like me. And then there's different engineers that will work on those components once you build the first prototypes. And then there will be another set of engineers that will actually work on those components after we build the very first cars that look just like the ones we're going to sell. And they figure out, oh, well, did this component actually perform as well as we thought it would? Is it doing what we want it to do? Is it as good a car as we need it to be? So there's a very wide variety of things to be done. Mechanical engineering, electrical engineering, materials science engineering, computer engineering. One big thing that people often don't realize is that when you're inside the car and you have your touch screen in the middle, or if you have a newer car, you have a touch screen in the middle, there's engineers at GM who need to figure out how to make that work. So that's computer science, electrical engineering. And then actually, that video that you saw, I don't know if you noticed, but the guy driving the car was also an engineer. So the guy driving the car was a chassis controls engineer, so his job is to make sure that all the active controls in the car, stability control, traction control, work as they need to. And as part of his job, he drives the car on a racetrack. So if you want to go be a race car driver, you could actually go be an engineer. So that's all I got for you guys. But if you guys have any questions about automotive industry, how to get into it, what goes on in, behind the scenes, I'll be around afterwards. So come by. I'll be happy to answer any questions. Thank you.